All right, so for the purpose of this lab is to prepare pieces of charged tape and observe their interactions and determine how much excess charge is on one piece of tape. The model, right, you're just using charged pieces of tape. So you place a piece of tape on a table, place another piece of tape on top of it, rip it off, taking some of the valence electrons off of that tape. You get two of those, and you place one piece of charged tape below another, and you see how far it goes up, and you make some calculations and conclusions based off of that. One on the model on the right kind of shows where if you have a charged piece of tape, it'll attract neutrally charged objects, right, like a hand or an uncharged pencil, and then it'll repel similarly charged objects, where if you put like a pencil and you rub it on fabric and you put it next to it, it'll repel the piece of tape. Here's some of the physical principles where you're looking at force, E fields, and then some of the constants that we used in our equations, right? Force is just like charges will repel each other, and reverse charges will attract each other, and F is equal to charge times E field. E fields is 1 over 4 pi epsilon naught times the charge over the distance squared, where the distance is just between 2 point charges. The result preview is when placing similarly charged pieces of tape next to each other, the upper piece of tape was about 3 centimeters, and on the tape there was the charge, that number of atoms, and that ratio of electrons to atoms shown right there. So in the calculations that we did, so you had the length of the tape density, tape mass, distance between the tapes, so you can calculate the gravitational force using the mass, and then you set F net equal to 0, where the electric force is equal to the gravitational force. You can move some of those terms around, and you find that the excess charge on the tape was negative 1.2 e negative 8, just because it's electrons, right? So you choose the negative charge. Calculations 2. The tape width is 2 centimeters, which you can use with the tape length to calculate the area, which is 30 centimeters squared. The length of an atom is 1 e negative 10 meters, and I counted that as a diameter. So I used the area of an atom, I just treated it as a circle. So you can use that to calculate the area of an atom, and then based on that, the number of atoms per piece of tape, based on the size of the tape that I showed before. And the number of electrons, you can just take the overall charge shown on the last slide and divide it by the charge of electrons, so that's right there. And then the electron ratio is just how many electrons are there for an atom. So for every 5.1 E6 atoms, there's 1 electron. So here's the code, right? So in the original model, we said that a piece of tape, we're just going to model as a point charge, and then we can calculate some distances and make some conclusions there. Did the same thing here, where you have your constants, as shown in our regular calculation, and then the physics calcs, they're all the same. And then the thing that's different about this one is you have visuals to represent it, where you have the two charges, which are the piece of tape, or the pieces of tape, shown by the white spheres. And then you have the force of gravity shown by the red arrow and the electric force shown by the blue arrow, where it's all acting on the top piece of tape. Another difference between the physical model and the code model is there's less rounding error. I did some rounding in my initial calculations, but here it's all going to be in the computer, so there's going to be much, much less rounding error. You can see the conclusions given by the code in the bottom left-hand corner. So for the discussion, some of the assumptions that we made were that the charge was evenly distributed across the piece of tape, right, because we can represent the tape as a point charge given that assumption. And then the only forces on this system are going to be electrical and gravitational force, and there's no air resistance. Other possible errors are measurement, right? It only worked once. The tape only went up, right, one time. So it happened very quickly. So it was kind of hard to make an exact measurement. I just saw that it was about 3 centimeters. For the final discussion questions, what if electrons had positive charge and protons had negative charge? It's a pretty semantic question, right? So nothing would change. No matter what charge they have, like charges repel each other. So if we, say, lived in a universe where protons were the valence charges, the experiment would instead have excess protons, and the two pieces of tape would still repel each other because protons would repel each other. Why is it important to handle the charge tapes as little as possible? The pieces of tape discharged very, very easily, right? It happened many times while I was doing it. So you want to handle them very carefully so that you don't discharge